limit. And things have solid ones. I think it kind of makes sense. It's said that once the math teachers is not available, so one of the chef in the kitchen, she came to teach them about limit. And give a practical example. Okay. Well. For chapter 10 is about series and Taylor polynomials, and there are 6 sections. First section 10.1 is pretty simple. It's talking about the sequences, okay? And like I just said, there are 2 things you need to pay attention. One is about what's the convergence of sequence? What's how to recognize the pattern of a sequence? Okay. Let's begin. So terms of series, well, for sequence, terms of sequence and convergence of divergence of sequence, and also linear convergent sequences, 5 patterns. There are 3 major points in this section. Okay, and the definition of sequence, basically, you think of sequence actually is a function. Notation for sequence, for instance, I have say A sub n. You can write this A sub n ends from 1 to infinity. And A sub n, you think of it just be you can think of A sub n actually equal a function of n. N is the positive integer. Okay, so this function is mapped from what? From the positive integer to real numbers. Okay, you can write A sub n, which will be n term of the sequence. Okay. For example, perhaps let's see here. People need the new whiteboard eraser. Okay, what's that? Please stand up. Yeah. So A sub n is equal to f. N is equal to, for example, it's the 2 times n minus 1. So the sequence will be 1, 3, 5, 7, and so on and so forth. Okay. And this A sub n is n term of the sequence. Okay. An entire sequence is denoted by either. You can write a sequence as this or that. Okay. So you can write this 2n minus 1. And for this, it's pretty simple. I'm writing the first 4 terms. And the first one, A sub n, is 2n plus 1. The first 4 term will be when n is 1, which should be 3, 5, 7, 9. And the second one, B sub n, is equal to 3 over n plus 1. So B sub 1 is equal to 1 plus 1, 3 divided by 1 plus 1 is 2/3. And B sub 2 will be 3 over 3 will be 1. And V3, V sub 3, V3 will be equal to 3 over 4. And V sub 4 is equal to 3 over 5. Okay. This is a very simple example. And how do we set how we define a sequence and say how we determine if a sequence is convergent or divergent? So we say this sequence is convergent if what? If limit the nth term, the limit of nth term is equal to, say, equal to 8, a constant. If this exists. And if the limit does not exist or equal to infinity, then we say this sequence divergent. It diverges. Okay? The sequence is divergent on the other hand. Okay. So on determine, we find the limit, and we all know whether the sequence is convergent or divergent. The first one, A sub n. This one, A sub n, so limit a n is equal to limit of 3 plus minus to the n. So you'll see this, when n is 1, right? When n is 1, a1 is equal to 3 plus minus 1 is 2. When n is 2, a2 is equal to 3 plus minus 1 to the 2 power squared, so be equal to 4. And when n is 3, a sub 3 equals 3 plus minus 1 to the 3 power, so equal to 2 again. And n is 4, you see a sub 4 equal to 3 plus minus 1 to the 4th power will be equal to 4. So the sequence, you will see the sequence will be 2, 4, 2, 4, 2, 4, alternately, 2 and 4. So that's why this does not exist. So the limit does not exist. So this sequence is divergent. Because the final term, the last term, a sub n, a sub n, the nth term, the limit of nth term does not exist. Therefore, I imply a sub n diverges. Okay, here's this one. How about B? B is the a sub n is 1 minus a sub n equal to n over 1 minus 2n. Okay? So limit of a sub n is equal to limit n over 1 minus 2n. So this limit is equal to, I divide by the numerator and denominator both by n. So be n divided by n, 1 over n minus 2n over n. Okay. And this is equal to 1, this is equal to 2, this converges to 0. So therefore, this converges to -1/10. Okay, therefore, the sequence diverges. And that's why it's the same, it's similar. It's a ratio of 2 to the n over 2 to the n minus 1. So I take a limit as n approach to infinity, you will see that the numerator become 1. So I divide, for numerator on the denominator, I divide them by 2 to the n power at the same time. So numerator will become 1, and the denominator will become 1 minus 1 over 2 to the n, and this will go to 0. So the limit converges to 1. So if the part A is a divergent sequence, actually it's an alternating sequence, and part B and part C are convergent sequence. Okay. And this is the just a notation, n factorial. N factorial is an n factorial. It's 1 multiplied by 2 times 3 times 4 times and times up to n minus 1. Okay, that's the factorial. Okay. And we also define the 0 factorial equal to 1. That's one thing we need to remember. Zero factorial is 1, and 1 factorial is 1. 2 factorial is 1 by 1 times 2 is 2. And 3 factorial is 6. And 4 factorial, this is 24. And 5 factorial is 120. 6 factorial is 720. But we need to kind of get familiar with the first couple of factorials. Because it's easier for you to recognize pattern of the sequence. Okay. Questions so far? Any question? Any question? Any question? Anyone? Question for me? Okay. Okay. Let me ask you a question. 2n factorial and 2n with a parenthesis factorial. Are these two the same? Are they different? we probably only have because next week we are going to have the review quiz. Okay, you can see the caption of the AI. We are going to finish some loose ends today because today is probably the last lecture because the next week we are going to have a review quiz, and then the week 2 weeks after today there will be the final exam. Okay, so for basically we pretty much finished chapter 10. Only one thing we didn't quite get is for the Taylor theorem, that's the about a remainder term. Okay, remainder. Let's see. Let's look at the formula first. Okay, Taylor's theorem is remainder. Okay, that's what we're going to discuss today. For the Newton method, we are not going to prove it because it's the application of first degree expansion, Taylor expansion. Okay. So recall if this function is continuous and it can be differentiated infinitely, then I can write it as the power series. Actually, we are going to use the Taylor series. So its summation n from 0 to infinity, and the n is the derivative, and this a is the I'm going to expand the function at x, at ax. So it's centered. This is the Taylor expansion centered at x equal to a, and factorial x minus a to the n. I can write it this way. However, in practice, it's not applicable to have an infinite sum because you are going to sum out infinite terms. This is essentially impossible. Therefore, you might think of, okay, I can write it as the first n terms. I'm going to just change it as let's just use k, subscript k, instead of n, because I'm going to find the partial sum. So that's the k factorial, k power. So I'm going to do it this way. K from 0 to n. And plus from so it is the is then the nth degree Taylor polynomial is what we can write as the actually notation is s of n of x, which is the nth degree Taylor polynomial. Okay, and the rest this is so-called remainder term. I can write actually is the notation is r sub n x, and this r sub n x is this, and actually I can write it. It needs some proof. We can write this way is the summation of instead of our inference sum, you can write it as f the m plus 1 derivative divided by m plus 1 factorial, and then here's x minus a to the m plus 1 power. Because use the textbook or the PowerPoint using the C, because the center is C, but I like center A better. Okay, and here, remember, here is the C. It's a graded C. Basically, it's kind of odd on this one. What's this C? It's a number. C is between where C between what? Between x and a. You can think of x is just some constant you plug into. For instance, you want to find f of 3, then x will be 3. Okay. You want to find you want to evaluate the function as 3, will be f of 3. So x will be 3. Okay. Because I'm not sure. We don't know whether x or a is bigger. But the only thing we know is that this number C is between x and a. And this is kind of amazing result because see, this the inference series Taylor series can be broken into two parts. The first part is the nth degree Taylor polynomial. And the second part, actually is the remainder term, actually is the infinite sum. However, it can be proved is equivalent to this, only this term. Just the m plus 1, the derivative plug into the number c, which is between x and a, and then divide by m plus 1 factorial, and multiply by x minus a to the n plus 1 power. How are we doing on time? Okay. So any question for this part? Oh, that's very important result. Okay, so if I want to use so suppose I want to use the nth degree polynomial to approximate. For instance, let's see. Let's try this question. So how close do you see the nth degree Taylor polynomial to approximate the original function? This remainder term will tell you how close your approximation is to the original function. Question? That's good. Jenny practice. You just really pay attention. Just read the vocabulary we will give every week. Right? We find that there are not many. The vocabulary we have for this semester. Approximately like 140, maybe in total, maybe. I mean 140 words. Okay, for instance, I want to approximate. Okay. We want to approximate e to the minus 0.75. Using the S8 of x, which is the 8th degree Taylor polynomial. First of all, let's see. E to the, if fx is e to the minus 6, right? Then we do know that e to the x can be written as summation n from 0 to infinity. Thus, you can prove it on your own. It's not difficult. It's n to the n power n factorial. We know that, right? So this will be summation from n to 0 to infinity, and that will be minus x to to be n's power divided by n factorial, so be summation n from 0 to infinity, minus 1 to the n power x to the n factorial. Okay, so the nth degree, the Taylor polynomial, which is equal to, I just need to have n power, okay? So when n is 0, there will be 1. N is 1, there will be minus x. N is 2, there will be plus x squared over 2. And, oh, sorry. Let's make simpler, so use S4, the first degree polynomial. Okay, so this will be equal to minus will be 3 factorial will be 6, and x to the 3 power plus 4 factorial 24, x to the 4 power. That's the fourth degree polynomial. That's all.